We already knew in the part before, in order to calculate the work of a constant force, so we can use the formula, which is work of the weight is equal, or work of the force is equal to F, the force, multiplied by the displacement, multiplied by the cosine, the angle between the force and the displacement. Now, the work of the weight, you can use another formula in order to calculate it, which is derived from this one. So we know that the weight has work if it's capable of moving an object from a certain position, from a certain height into another height. So in this case, we know that the weight has work. So this is why we can say that the work of the weight is due to the variation in the height of the body. So during its motion, which means it depends only on the height and it does not depend on the path of the object. So this is why we can say that the work of the weight is given by the mass times the gravity times the initial height minus the final height. So the object is moving from a certain height into another height, and its height is changing due to the work of the weight. In this case, we have to pay attention that we must take a reference in order to determine the height of the object. So let's take now an example. Let's suppose we have a small ball that's freely falling from a certain height. Let's suppose it's freely falling on the ground from a certain height, A, here, where we have the initial height A is equals to 2 meters. And then this ball reaches the point B, which is at a certain height. So this is the height A at point A here, and this is the point B here, such that the height B is equals to 0.5 meter. So in order to calculate the work of the weight during the motion of the ball from the point A into the point B, knowing that the mass of the ball is equals to 2 kilograms, we can use the formula that we already said. So the work of the weight equal the force, which is the weight, multiplied by the displacement, which is AB, and multiplied by cosine angle theta. Now, the weight is given by the mass times g. Now we have to pay attention that in order to find AB, this means this part here. So we know that AB, this path, is equals to, so if we can write here, AB is equals to 2 minus 0.5, which is mean it's equal to 1.5 meter. So it's height A minus height B. This means we just did. So height A minus height B will give us what? Will give us this part, which is AB, which is the displacement. So then we can continue the calculation. So it's here, it's AB, which is 1.5, and cosine is the angle between the force and displacement. Now the weight, this is the direction of the weight, and AB also, this is the direction of AB here. So they are parallel and same direction. So this means that the angle is equal to 0. So cosine 0, which means that we can do another calculation is 2 multiplied by 10 multiplied by 1.5. So we'll get at the end equal to 30 joules. Now, this is the formula that we took last time, but in order to calculate the work of the weight, now we can use the formula that we wrote. So mass times the gravity times initial height minus final height. So in order to calculate the work of the weight, we usually use this formula. So equal the mass, which is 2, 10, initial height is the height of A, minus final height is the height of B, and then we can continue the calculation, so which is 20 and multiplied by 2 minus 0.5, so we'll get at the end with 30 joules. So we will use this formula in order to calculate the work of the weight. Let's take now another example. A box of mass M equal 5 kilograms is thrown from a point A to point B along an inclined plane, making an angle 30 degrees with the horizontal, such that AB is equal to 200 centimeter, which means it's equal to 0.2 meter. So we continue here. So it's equals to 2 meter. So we continue here. Determine the height of the point B. We know that if this is the reference, okay? So we know that the angle here is equal to 30 degrees. Height B is opposite to the angle 30 degrees. So we have to use sine. So we'll say here, height B equals to AB sine 30, which is equal to 2 sine 30. This means equal to 1 meter. So this is the height of B. Now determine the work done by the weight of this box along its motion from B to A. So the object is moving from B to A, and you have to calculate its work. So the work of the weight equal to the mass times G. Initial height is the height of B. Final height is the height of A, since it's moving from B to A. So it will be equal to the mass is 5 multiplied by 10 multiplied by 1 minus 0, since A here is on the reference. So we'll get here as answer, it's equal to 50 joules. Now the last question, deduce the work, so it's a deducer, the work done by the weight of the box as it moves from A to B. So it's moving now from A to B. In this case, so this is from B to A. Now the work of the weight as it moves from A to B, so equal to negative the work of the weight when it's moving from B to A, which is equal to negative 50 joules. Since if you have to verify it, the work of the weight when moving from A to B will take, initial height will be A and the final height will be B. So it will be 0 minus 1, and then we'll get here negative 1. So during the motion downward, the work of the weight is motive, while during the motion upward, the work of the weight is resistive.